ResNet simplified. So what is ResNet? ResNet stands for residual network, which is a type of artificial neural network architecture commonly used in image recognition tasks. Neural networks are like complex mathematical models that learn to recognize patterns in data. So in the case of ResNet, it's specifically designed to improve the performance of these models when dealing with deep neural networks which have many layers. So imagine a simple example, a neural network trained to recognize handwritten digits. So the input to this network would be the image of a handwritten digit, that is 0 to 9, and the output would be the corresponding digit. This network is trained on large data set of images and their corresponding labels or the digits. So ResNet is a way to improve the performance of this network by making it residual. So instead of directly learning the relations between this input and output, the network learns the residuals or the difference between the input and desired output. So to understand this better, let us take a simplified analogy. Imagine you have a recipe for making a sandwich. You want to create a sandwich that is 6 inches long. Your recipe may have several steps such as adding bread, adding ingredients and assembling the sandwich. So a standard neural network would learn the recipe step by step, gradually building that 6-inch sandwich. However, a ResNet would learn the difference between the current sandwich length and the desired 6 inches. So if the current sandwich length is 4 inches, the ResNet would learn to add 2 inches. That is 6 minus 4, that is 2 inches. So this residual learning approach makes it easier for the neural network to learn complex relations, especially when the network has many layers. It also prevents the vanishing gradient problem, where the gradients used to update the network becomes vanishingly small as they propagate through many layers. So ResNet has proven to be a powerful architecture for image recognition tasks and been widely used in various deep learning architectures including object detection, image segmentation and more. So why we use ResNet? Why it is so popular? So ResNet is popular in the field of deep learning for several reasons, primarily due to its ability to overcome the challenges associated with deep neural network. So when the neural networks have many layers, they become increasingly difficult to train and the performance can plateau or even degrade. However, ResNet addresses these challenges in several ways, making it a popular choice for many applications. First is the improved performance. So by using this residual connection, ResNet enables the network to learn complex relations more effectively, resulting in better performance. And this is evident in several image recognition and computer vision tasks where ResNets have consistently achieved state-of-art results. Then it overcomes the vanishing gradient problem. So in the traditional neural networks, gradients can become vanishingly small as they propagate through many layers, making it difficult to train the network effectively. So these residual connections help mitigate this issue, allowing gradients to flow more easily through the network, which results in better training. Then scalability. ResNets are designed to be easily scalable, means they can be extended to have a large number of layers without sacrificing performance, which makes them ideal for applications that require deep neural networks such as image recognition and video processing. Then comes modular design. So ResNets are constructed using modular building blocks, making them flexible and easy to customize for different tasks. Researchers can modify and experiment with various components of the network, such as the number of layers or the type of residual connections, to improve performance for specific applications. Last but not least is the efficient training. So these ResNets are relatively easy to train compared to other deep neural network architectures. This is due to the residual connections, which make the optimization process more stable and less prone to getting stuck in local optima. So here is an example of how ResNets have made an impact in real world. In 2015, a team of researchers used ResNet to win the ImageNet large-scale visual recognition challenge. a prestigious competition in the computer vision community. And there they achieved a top accuracy of 95.3% and top 5 accuracy of 97.3%, vastly improving the previous state of art models. And this breakthrough demonstrated the power and effectiveness of ResNet architectures. Well, these advantages makes ResNet a powerful choice in the various deep learning applications, particularly in computer vision tasks such as image and video processing, object detection, and facial recognition. Thank you.